Now, in order to create a good solder joint, it's important to heat both the workpiece that you're trying to solder, the board that you're trying to solder it to first before you melt the solder into position. So we place the iron tip on the part and the board so that it's touching both at the same time. And after a few seconds, we touch the solder to the tip and then allow the solder to flow into the joint. Pull away the solder and then the iron. In a few seconds, the solder will cool and we have a good solder joint. One of the challenges to creating a good solder joint on certain parts is that some pins can be connected to a ground plane. And in this case, we have a large copper area which acts like a heat conductor, which will try to pull heat away from the solder joint as you're trying to solder that part. So it's important that you apply extra heat to certain pins. Now, first you need to identify which pins are connected to the ground plane. In this case, we see this pin here, which has a slight X shape through it. That's a thermal relief connection to a ground plane. And this thermal relief will allow us to apply enough heat to the part. We still need to take extra care to hold the iron in place for long enough time to make sure that it reaches temperature before we apply the solder. So now that we've identified that part, we can load our resistor. Place it in the vise. We clean our iron. Apply the tip to both the printed circuit board and the wire on the resistor. Give it a few seconds. And after a few seconds, it gets hot enough to begin flowing the solder. And you can see it took a little bit longer than the other pin. So it's important to wait that extra time to ensure a good solder joint to a ground plane. For comparison, we can look at the other pin, which is not connected to the ground plane, and this one will solder quite a bit more quickly. As you can see, that took a few seconds less.